This is going to be a long video which we're going to show that we've calibrated this Tri-Track Rover robot with a magnetometer such that we can track its orientation using our compass over here, which is a Java bean, and we're running a Java application. Now the key point is that this rover is on the networked robots system, and we can see that with the flashing blue LED. That means that we're on the network, we're connected. And what we're going to do is first give you a quick rundown on the Tri-Track Rover. So basically there's the big battery we have, which is 12 volts. We have two motors in the rear, and this is of course the tank track. And if we go to the top, we got two ultrasonic sensors. Now, going on the top, the key point is to show the magnetometer. So here we see the magnetometer, and it's going to the I2C bus. Over here we have an I2C bus which has two sides of 5 volt and a 3.3 volt. We're going to the 5 volt. This is a magnetometer from Pululu, which also has the capability of inputting 5 volts and converting to 3.3 on the magnetometer, which is an SD micro magnetometer. Now if we go look here, we have the processor. You can see that chip right there is a PIC. It's a microchip 32-bit processor. It's a PIC 32MX360 F512, and it's basically controlling. We have our software in there which allows commands through the network robots in order to measure sensors and also to control motion of the Tri-Track. Also here we want to show the Wi-Fi unit, which is how we're communicating. So the Wi-Fi basically has an internal server which we connect to, and this is then on the network, and then it sends data out serially to the 32-bit PIC SoC, and that of course measures the magnetometer, okay, and sends it back over the network. Right, so here we have the Linux box, which is actually has the frontline server, which is connected. You can see a bunch of measurements through the magnetometer showing. Okay, this is actually a database with all the robots using MySQL Workbench. Okay, so what I'm going to do is place this camera on its stand, and then we're going to rotate the Tri-Track and see if we can track the orientation. Now all of this is going through the network robots. So this is through a network, which we have the frontline server and the WebSocket router server, okay, which is on the website, robotics.networkedrobots.com. Okay, so the orientation of the Tri-Track Rover is currently, this is the front, because we have the two sensors there, even though the processor and everything is on the back. Now this is pointing toward east. Okay, so this is pointing toward east, and we're showing that on the compass. So we're pointing toward east. Now we're going to rotate this, and as we rotate, you'll see the compass, the needle move. This is kind of, we're using basically the compasses to show the northeast, southwest, so we know the orientation, but we actually have a needle that shows the orientation of the rover. Okay, so with that background, let's get started. Okay, so let's orient this guy so we can see the compass and also the Tri-Track. Now the Tri-Track is on a brick, which is good, and what we do is cover the brick basically with so that we don't scratch anything with a saran wrap, and then we're going to rotate the rover like this. Now we can also put this on a platform and do a tanking and see the orientation as we rotate it, but here we want to do this in a controlled environment. So what we're going to do, we're going to actually rotate this guy, and as we rotate it, we can see the compass over here. Now notice that right now the front is, you can easily see that the front of the rover is where the ultrasonic sensors are pointing. Alright, so right now we're pointing east, and just for kicks, let's go ahead and get an iPhone and let's look at that. So here's the iPhone, and here's this compass, and you can see the get that light out of the way. So here we have the iPhone with a compass, and you can see that we're pointing toward east. Okay, and as we rotate, we're going to go south, west, north, back to east, and so forth. Okay, and track that with the Java bean over here. Okay, so let's get that Java bean into view, and I'm going to start. So I'm going to start rotating it, and let's look at the Java bean. So as I rotate, I'm going toward south. So now I'm pointing south. Keep rotating, I'm going to end up pointing west. Okay, you can see that. And if I keep rotating, I go toward north. This is the situation. So right now I'm pointing north. Okay. You can see the sensors over here. So I'm pointing north, and then you can see that we're pointing north on the Java bean. Alright, so what I'm going to do is keep rotating until I get back to my original position. So now I'm at my original position, which was pointing east. Little offset. Okay, let's take a look at that. So here we are. We're pointing east. So this pretty much shows everything. I'm going to do this again, and let's see if we can track, you know, as we rotate. Very smooth. So the key point here is we're able to measure the orientation of the Tri-Track, which is critical in mobile robotics applications, to know, you know, where our orientation is. Of course, with the accelerometer, we can know what our pitch and roll is. We also have a gyro on here, so we can know the rotation rate. Okay, and later we'll do a whole tanking business. So let me go ahead and rotate this again. So I rotated it. I'm pointing south. Okay, let's get that in there. This is south. Okay, and I'm rotating it. So now we're pointing toward west. Get an idea on that. Okay, here it is. So you can see that the sensors are pointing opposite directions, so that's west. And let's go ahead and rotate again, and we'll get back to north. So now we're pointing toward north. Okay, you see that? Sensors are pointing toward north. And we can see the compass also showing the needle pointing north. Now what I'm going to do is rotate and get back to our original position, which is where the front, which is the ultrasonic sensors, are pointing basically toward east. And we see that over there, and let's take a look at take a nice look at our rover here, and we see the sensors back in our original position. Okay, so we did a sort of a comprehensive video here showing that we are able to measure the magnetometer remotely anywhere from the internet. Basically, we're actually going through the internet to get the position from the magnetometer. We've already calibrated this Tri-Tractors. Go visit the website and you'll see the numbers. And so we're showing calibrated data, and it tracks perfectly the orientation. And we can show that with our Java bean compass. Okay, we'll start this again. Let's go ahead and stop the program right here. Now we're going to start it. There'll be a delay as we set up the network. We're now pointing toward south, a little bit off south. Okay, and we're rotating, and you can see the needle also rotating on the compass, tracking the orientation of the Tri-Track as it tanks. Okay, here we're pointing directly south, and you can see that we're pointing south on the compass. That was the final position.